we are going to be doing two examples of working with equations with fractions. Like we said in the concept map, you just need to know how to start these. Two things need to pop into your head. You need to think, I need to find the LCD. And the second thing is, we need to go state our restrictions. Okay. Now, let's start by looking at these denominators. There we've got an x plus 2. There we've got an x plus 2. That's great. But look what we've got over here. X squared minus 4. There is some potential over there. So always look for an opportunity to go factorize. Because at the moment, if we leave it like this and we don't factorize, the LCD would be x plus 2 times x squared minus 4. Now, I guess that can work, but look what's going to happen if we're going to factorize this. So these can be long and tedious. They can be like 6, 7 marks, and then students think, oh, it must mean that it's so hard, but it's not. There's just multiple steps. There's often sign changes. There's often factorization. There's your LCD. There's stating the restriction. So you just need to focus and not make a silly mistake. Do you see what I did there? I factorized x squared minus 4. It's dots. X minus 2, x plus 2. Perfect. Now what is our LCD? Our LCD is x plus 2. That's what we've got over there. That's also over there. And then it will be x minus 2. There's our LCD. What are our restrictions? Well, why are there restrictions with fractions? Is because our denominators can't be 0. Because if that whole denominator is 0, then it won't exist. It would be undefined, right? Because our denominator can't be 0. So we look at our LCD that we chose and we see what will make it 0. Well, either our x plus 2, if x plus 2 is 0, that's not good because then this whole thing would become 0. Or if my x minus 2 is equal to 0, that's also not good. Then it means the denominator would become 0 and it would be undefined. So that means that my x cannot be negative 2. Just took that one over, hey? And that also means that my x cannot be positive 2. Because if that happens, the denominator will be 0 and this will become undefined. Okay, the worst is over. We found our LCD. We had to factorize first. And we stated the restrictions. Okay, let's go make the denominators common. So I've got x plus 2, x minus 2. Well, how do I get from a denominator of x plus 2 to that denominator over there? I multiply the bottom by x minus 2. So I have to multiply the top by x minus 2 as well. Then the second one already has that denominator that is now common. So that stays the same. I'm going to put that in brackets just to see it as a unit. And that's a good habit because sometimes when this is a negative in front, we make sign mistakes. We'll get to that later. And now we also need to make this the common denominator. And when we do that, how do we get to the denominator of x plus 2 to this one over there? We multiplied the bottom by x minus 2. So we also have to times the top by x minus 2. Okay, great. Now that the denominators are the same, we can make it go away. A lot of students use the language and say we can just drop the denominators. Okay, that's fine. You can use that language. I can't tell you what to do. But actually, where are they going? We can't just drop stuff. So it means that I am multiplying my whole left-hand side by the LCD. And I'm multiplying my whole right-hand side by the LCD. So what I'm saying is I'm multiplying this side by x plus 2x minus 2. I'm multiplying the whole right-hand side, then they cancel out. And I'm doing the same with the left-hand side. So then all the denominators cancels out. And we are left with this. So that's the whole point of making the denominators the same, so that we can get to this point. So we got rid of all the fractions. That's good. And now we can just take it from there. I put these in a bracket. Remember, I commented on that earlier, because often when we don't, and there's a minus in front, students forget to distribute that in. So watch out for that. Okay, now we're just going to multiply this out. Don't make silly mistakes when we're not focusing. It happens to all of us, but let's try and avoid that. Plus x minus 4 is equal to 2x minus 4. And let's just put everything together. Minus x plus x, that's negative 5. And then we take, I think it's going to be that. We'll double check that just now. And I think that there we're going to land up with a 0. I'm just going to double check all of that. So we've got our 3x squared, which is fine. If I take this and I bring this over, it's going to give us negative 8 plus. Yeah, that should be fine. And I'm going to plus this on this side, and then they will cancel out. Yeah, I believe that is correct. So I don't have to write that 0. I'm just putting that as a reminder for now. And then how do we solve this? Let's just take out a common factor. You can also just put it in on your calculator. I'm just going to take out an x. Then I'm left with 3x minus 7 is equal to 0. So then students are often a little bit confused about this. It's just one bracket. Those two things are just being multiplied by each other, right? So we can just say it's either that x is equal to 0 or x is equal to, well, if 3x minus 7 equal to 0, so then x would be equal to 7 over 3. There we go. There are two solutions. Let's check them in the restrictions. It's can't be 2 or negative 2. No, we are safe. So both of those are solutions. If it was one of the restrictions, we would have had to write no solution. And that's it. Lots of steps, lots of work. You need to concentrate and focus, but very doable and lots of nice marks for you. Let's look at the next one. We look at those denominators. Okay, at this stage, sure, they're definitely not the same, but there's some potential over there. I'm just going to write this one as a fraction as well. I'm going to write that as 2 over 1. Now, if we look at the denominators as they are right now, remember, we've got equations with fractions, so we need to think LCD, and we need to think restrictions. At this stage, our LCD would be this. We don't want to work with this, because if we work with this, we are going to land up with an x to the power of 3 that we can't solve just yet. We want to stick to our quadratic equation. So let's see if there's anything else that we can do. Always go look for an opportunity to factorize. If we look at that first denominator, do you see the dots there? We've got 3x minus 2, 3x plus 2. There we go. Now let's see if that helps us in any way. Well, if I look what's going on over there, maybe it helps if we put the brackets around. Do you see any potential there? Well, if we swap these two around, then it will look exactly like that bracket over there. And that's what we want, because the shorter our LCD is, the better. So we want some of those brackets to be the same. Let's just write that one over. So let's just show, I'm showing all my steps. I don't want to make silly sign mistakes, and I'm obviously just walking you through this in detail. Okay, so what do we need to remember now with this grade 11? So if I go and swap that around, the sign in front needs to change, because when we do that, we are not changing to the original sum. We're just manipulating it, writing it in a slightly different way, but ultimately the sum stays the same. Okay, now we've got our LCD. We've got those brackets that are the same, and then we've got that other bracket of 3x plus 2. Okay, and there we've got our LCD. So we're going to make that the lowest common denominator. So it will be 3x minus 2 and 3x plus 2. And let's just quickly write down those restrictions. Remember, with our restrictions, we do not want the denominator to be equal to 0, because then it will be undefined. So your 3x minus 2 equal to 0, that would be one of our restrictions. And then our 3x plus 2 would be our other restriction. So x cannot be, that's 2 over 3. And x cannot be negative 2 over 3. So the worst is over. We found our LCD and we found our restrictions. Now, let's just be mindful about our signs. Let's focus, write all our steps if we make the denominators the same, that one is obviously already the common denominator, so that just stays what it is. This one over here, to make it the common denominator, I know that lots of you, or many of you rather, try and skip steps, but I like to just write it all down. Okay, so to get from a denominator of 3x minus 2 to 3x minus 2, 3x plus 2, I need to multiply at the top by 3x plus 2 as well. Do I have to write that 1? Absolutely not. All right. And to make that denominator, I multiplied the bottom by that. So I also need to multiply the top by that. So 2, 3x minus 2, 3x plus 2. Okay, now that the denominators are the same, I know that you say you drop them, but where are they going? We can't just drop stuff. I'm multiplying this side by that LCD, so then it cancels out. But in an equation, if I do something on the one side, I must do exactly the same thing on the other side. So if I multiply this side by the denominator as well, that would also cancel out. And that's why it looks like it's dropped. Okay, so we are left with 5x minus 3x plus 2. It's important that that is in brackets because that needs to be distributed in. And over here, we will be left with this. Okay, so far so good. We just need to be careful that we don't make a silly error. So let's just take our time and do that. Minus 3x minus 2. And over here, I'm just going to leave that in front for now. I'm just going to FOIL that out. 9x squared. That is actually going to give us 9x squared minus 4. Hey, so if you multiply that out, you'll see that is where we will land up. How did I know that? Well, I mean, I remember over here, before we FOILed it was 9x squared minus 4. And we can see that these are just the results of dots. Hey, the brackets are exactly the same. They just have opposite signs. Now, if you didn't see that, don't worry about it. Because if you're going to FOIL that out and simplify it, you're going to get there eventually in the next step. Okay, now let's multiply that 2 in, or let's just simplify the left-hand side. There I've got 2x minus 2, and then I've got 18x squared, and I'm taking away 8. Now we are just back to a quadratic equation that we need to solve. So I'm going to take everything that side, 18x squared minus 2x, and then take away 6. Let's see if there are some factors. So let's grab our calculators. My a value is equal to 18. My b value is equal to negative 2. And negative c for my 6 value. Okay, so we can't factorize this because I get an answer there with the square root. So that means we can't factorize. We have to use the quadratic formula. So now we have to go plug that into the quadratic formula. X is equal to minus b. So it's minus, that is a negative 2, plus minus the square root of b squared minus 4 times a times c over 2 times a, which is 18. I feel like my handwriting just went from bad to worse in this video. So there we're going to land up with a positive 2. What are we going to have underneath the square root? Well, that will give us positive 4. And that, if we multiply that out, it will give us a positive, I get that it is 432. So if we add that, that would be 436, and that will be over 2 times 18, which would be 36. And then obviously if we simplify that a little bit further, we will get to our two solutions. So I'm going to put that into my calculator. One that has 2 plus the square root of 436 over 36. And I'm going to make sure that you read the question carefully. If it says leave it in surd form, then that is what we will do. Over 18, or x is equal to, I'm just going to write the decimal, because if they said write it as a decimal and we round it off to 2 decimal places, you will have that. And then for this one over here, it would be 1. Oh no, I need to go change that to a minus. So this is the second solution. The first solution, I used the plus, and for the second one, I just use the minus over there. 9 over 18, and what is that decimal? It would be negative 0.52. So make sure that you read carefully whether you must round it off or leave it in surd form.